Newton's law number 1. An object in uniform motion will stay in that motion until an external force is applied. Here we have your average soda bottle. No external force is currently being applied to it, and since it was standing still when this started, it is currently standing still. Now, if an external force is applied, say my hand hitting it, it will roll until the point where it hits something else, or the friction from the ground, which is from gravity pulling it down towards the ground, affects to stop, which is also an external force. Let's try this out. There, it actually nicked the wall. If we did this again and we did it better, it would keep going until it hits some force with enough, some object with enough force where it stops completely. There, friction completed it. Now let's try one more time, having this hit something solid so that solid external forces applied all at once. There, the object stops. Thus, it is in motion until an external force is applied. Newton's second law, that an object's mass and the force applied on it change the rate of acceleration that an object gets. Now, if I take this empty soda bottle and give it a little bit of a push, it goes about yay far. Now it'll go back a little bit so it can find its center and rest easier. Now, if I take the same empty soda bottle from the same spot and push a little bit harder, well, it turned, but you could obviously see that it went farther. Now if I take this soda bottle, turn on the lights, open it up, fill it up with some water, which I will do via a cup, due to the fact that it does not fit under the sink. Now this water will add some mass to the soda bottle, which should differ the result in this experiment. Now, I need to fill this thing up all the way because otherwise the external force applied on the bottle, there will be an extra external force applied on the bottle, which will be the water shifting weight while inside the bottle. And that would ruin the whole experiment. So top it off, put the cap back on, turn the sink off, not to waste water, check it, looks pretty good, turn the light back off, not to waste electricity, and bring this back over here. Now, same exact soda bottle, about the same place where I was before in the rug, so that shouldn't really affect it. Now, if I gave this soda bottle a little bit of a push, about the same as I did for the first time, it barely moves. Now, the mass of it is a lot heavier, which means more force will need to be applied for it to move the same distance that I did for the first experiment. But, just like the first experiment, if I push harder, it will go farther. Now, since there is more mass in this, it will also stay in motion more. But, once again, that's Newton's first law. Newton's third law. For every action, there is an equal and opposite reaction. Now here I have two 2-liter bottles, an A&W and a Dr. Pepper. Now, the fact that they're different pops doesn't really make a difference, but they're empty, so it should make the experiment pretty interesting. Now, when these two objects collide, since there will be an equal and opposite reaction, while they hit each other and push off of each other, they will also have a force that will, since the force applied to the other one will also come back to this one, not only will they stop, but they will move slightly backwards. Now, let's test this out and see what happens. Now, as you see, they move slightly backwards and they didn't just stop when they hit each other. This is Newton's third law. With every action, there's an equal and opposite reaction. Thus, when I pushed on them also, my hands were slightly pushed backwards, but due to the fact that my force was so great, it was very minimal and pretty much undetectable.